Okay, again, this is the next episode of BobCAD's webinar series. Today's topic is going to be 3D Programming Boot Camp. My name is DePoalo. As you know, I'm the voice of the AfterDark video series. You can find me on Instagram at DePoalo. You can also look up hashtag BobCAD-AfterDark. You can also find me on Facebook and YouTube, as you know. The goal of today's webinar is to help you get more out of your CAM software by showing you how to use common 3D toolpaths and options. There's 3 cutting strategies that we're going to really take a look at. These are the most common cutting strategies you'll use when machining 3D parts. We'll look at Z-level rough, Z-level finish, and planar. Z-level rough, this is typically used to remove the bulk of the material. You can think of it as a 3D pocket. It's going to step down level by level and pocket out or pocket in, following the surfaces or solids you've selected. We're also going to look at Z-level finish. Z-level finish you can look at as like a 2D profile. This is best for steep areas of the parts. The more vertical in nature, or the steeper the angle of the part, this toolpath does a really good job for it. Again, it's going to step down the model following the surfaces or solids, and you could think of it as a 3D profile, following the surfaces or solids, great for steep areas. The last one we're going to look at is planar. Planar, I guess, is a little more difficult to kind of categorize. The best that I could come up with is it's like a 3D face cycle. It's going to move back and forth following the surfaces and solids you've selected. This toolpath is best for shallow areas of your part. And again, it's going to run back and forth at a defined angle. Okay? So these are the strategies that we're going to look at today. The other thing we're going to look at is geometry selection, selecting a model, selecting a surface or multiple surfaces, and then also using boundaries to control where you're cutting and where you're not cutting. 3D toolpaths are based on the surfaces and solids you've selected. You can select a single surface, you can select multiple surfaces, and you can select solids. The toolpath will only consider the surfaces that you've selected. So what you select plays a huge role in where your toolpath is being generated. Okay? We're going to talk about controlling your toolpath by your geometry selection, your boundary, your top and bottom of job, and then also using additional surfaces to control where your toolpath is being generated. Common questions we're going to answer is how to keep my tool away from, how do I stop the toolpath from going any deeper, and how do I extend my toolpath past the edge of the part. The next thing we're going to look at is we're going to talk about the different options. There's about 12 different options that you can change on average between the different toolpaths. This may seem like a lot at first, but really once you get into it, it gets a lot easier. Here's some tips for you. Change one setting at a time. When you're editing your toolpath options, whether it's patterns, parameters, leads, or links, just change one option at a time and recompute your toolpath. The other thing to do is to experiment, try different things and see what happens, and most importantly, find the similarities between one job and another job. Find what's similar between the strategies and what's consistent, what kind of results that you get. Now, a very important note to make is when you're generating your toolpath, you want to use a reduced machining tolerance. The reason why we do this is it allows for faster toolpath calculations. The default tolerance is 5/10 or 0.0005. You can reduce the accuracy and the calculation time by changing this number to 1/1000 or 0.001 or whatever number that works for you. Okay? Tips: when you make a change to update the toolpath, you have to recompute your toolpath. You're also going to want to use things like blank and unblank to hide your toolpath so you can see what's going on. And then also using backplot, which is the ability to plot out where the tool's going to go with your toolpath on screen. This way you can see where the tool's going to start and where it's going to end cutting. Okay? The other thing we're going to talk about is working smarter. You know, these cutting strategies whether it's the tool that you're using or the material that you're cutting, these are really, there's a lot of consistency of when and where and how to use this stuff. So instead of starting from scratch every time, we're going to talk about saving and loading features and copying and pasting features so that you can use information that you created or defined in one machining strategy and you can use it in others. Okay? Like always, to learn about the latest in cutting-edge CNC programming technology, call us today. Our number here is 877-262-2231. You can dial extension 123. You can find us on Facebook, YouTube, Twitter, Instagram, hashtag BobCAD-CAM. So let's go ahead and get started. I'd also like to thank everybody for coming here today. I really enjoy putting on these webinars. They're a lot of fun for me. When working with you guys, I got a lot of really good feedback from the last time, or the last webinar, and I really enjoy doing these. So thank you guys so much for spending some time with me here today. I'll try to keep the explanations very concise and to the topics at hand so we can keep moving forward. All right. Okay, so where are we going to get started? Let's see here. Give me just a second and we'll get the first file loaded in here. All right, let's see here. Okay, so this is the first part that we're going to work on. Now, I have about 15 different files that I've prepared for today. Some of the files are the same as last week, and some are additional new files. All right. So bear with me here just a second while I get set up. Okay. Let's see here. I should have, you guys should be able to see my screen, so that should be good. Give me just a second here. I apologize. Okay. All right. So here's our sample part. Now, one of the first things that I'm going to do, and I'm just going to go through this one time. I'm going to copy this file. I'm going to create a new file, and I'm going to paste it. So this is a solid model, and what we want to do is we want to put toolpath on it. So when you're starting a new job, once you have your part drawn, you'll go to your machining job. You'll pick the type of job and then the machine. So we're going to do milling with a 3-axis machine. We're going to run through the stock wizard. There's a bunch of different types of stock that you can work with, but rectangular is going to be the most common. It's just going to put a box around the geometry that's on the screen. So it's going to look at the minimum, maximum, and it's going to put stock around it on all sides. Okay, you do have the ability to adjust the stock on either side, left or right, top and bottom. Okay, and you also have the ability to set your origin, your zero, your touch off. Okay, so once you've set up a job, now you can start loading in toolpath. Now how you load in toolpath is you go to the machine setup here and you right click. When you right click, you can get into the different cutting strategies. You can choose one, like in this example, 3-axis. Okay, so again, if you want to load a toolpath, you're not going to find it on any of the toolbars or any of the pull downs. And even if you right click, what you want to do is you want to right click on your setup and then go to mill 3-axis. Okay, from here you're going to see a list of different cutting strategies. Depending on the version of the software that you're running will determine what strategies are available to you. For today's webinar, I'm going to focus specifically on the mill standard cutting strategies. Okay, so that's what we're going to talk about here. So if you're a mill standard user or a mill professional user, the strategies we're going to focus on are Z-level rough, Z-level finish, or planar. These are going to be the 3 that we're going to look at. Okay, there are 3 more in standard, and then there are 7 more in pro, and then another 7 in advanced. So there are a lot, but this is a boot camp, so we want to cover the basics. Now, once you choose a strategy like Z-level rough, what you're going to do is use the wizard style where you can next through or go to previous, and you can answer the questions as you go. The other option you can do is you can go to the Explorer view over here, and you can click on the different categories. So you can either next through, or you can click on the different categories. Okay, the tool is for your tool. The patterns is for the cut pattern. Different strategies offer different patterns. Parameters, this is depth of cut, stock for finish, allowances, machining tolerance. Leads, this is how the tool comes into the material, and then there'll be different options. And you'll find a consistency between the different strategies of patterns, parameters, leads, and options, okay? In this case, I'll just set this to a 1/2" end mill. I'm going to leave all the other settings defaulted. I'm just going to adjust my machining tolerance here. I'm going to reduce it so we can compute faster, all right? From here, we're going to go ahead and just compute our toolpath. I'm sorry, I forgot to select the toolpath. So when you go through the wizard, when you're in the wizard, one of the first steps is to select the geometry. And this is actually a great point. If you don't select it from the wizard initially, then you don't get an option to select it from the wizard. Where you would select it from is in the tree. You have your 3-axis feature. It says geometry. There's a red plus sign there. That means you can add something to it. We'll right-click on geometry, reselect, select all, spacebar to lock it in, okay? If we want to compute our toolpath, we can go to the operation, right-click, and choose Compute Toolpath, and then what that's going to do is generate the toolpath based on the geometry that we've selected, okay? So we'll go ahead and reselect here, recompute. Getting a weird result there, but that's okay. All right, so we get a feature, geometry, we input our settings, we compute, and we get our toolpath. Now, one of the things in the process of going through that, let me delete this here. The process of going through this is you're picking a strategy, and you're going step by step, and you're answering all the questions, okay? Now, the way that you define this, depth of cut, stock for finish, step over, these are pretty consistent with the tool that you're going to use and the material that you're going to use. So to work smarter, we are going to save and load or copy and paste these cutting strategies, and that's going to make a big difference in the way you approach programming your jobs. Instead of starting from scratch every time, what you're going to do is save and load this information and use it for other jobs. Okay, so let me close this here. We'll go back to this file. Now in this file here, what we have are some sample features. Okay, so let's talk about the 3 strategies. We have Z-level rough, we have Z-level finish, and we have planar. So let's select our geometry, select all, spacebar to lock it in, right-click on the operation, and compute. Okay, so this gives us our toolpath. This is Z-level rough. Z-level rough, like I said, it's like a 3D pocket. What the tool's going to do, if we look at it from a side view, let's go to right, you can see that it's just going to create a level. This depth here, this is your depth of cut. It's going to create a level, and then it's going to offset pocket in, and then it's going to step down to the next level and offset its pocket in. You can see as there's the curvature on the wall of the part, the toolpath is going to follow the curvature on the wall of the part. So again, Z-level rough is used to remove the bulk of the material. You can think of it as a 3D pocket. Whatever surfaces you select, you compute it, it's going to remove the material out to the stock boundary, okay, and that's really important. You have different ways that you can control where the toolpath is going to cut. One of the ways is with the surfaces you select. Another way is with a boundary to limit it. You also have some settings within the toolpath feature to control different levels, and then you also have things like stock can be taken in consideration depending on the strategy. Z-level rough particularly uses the stock as a boundary, okay? So Z-level rough is like a pocket. We can come to this operation, we can right click and backplot. This is going to show our tool. It's going to show where we're going to start cutting and where we're going to end cutting. It's going to show the direction that it's going. You can click right through to this. Now, one of the reasons why you may choose to backplot your toolpath is really to get an idea of, do you have enough clearance with your hangout or with your tool holder? This is a really quick, fast, easy way to check if you have enough flute or if you're going to have a holder conflict. Now, it's not going to check against the holder. It's just displaying where the tool is and where it is in the toolpath, but this is a really good tool that you can use. Okay, great question just came in from Brian. Brian asked, how am I toggling between the wireframe? Okay, there are some hotkeys that you're going to want to get to know, get familiar with, or to get to know. One of them is S for surfaces. It's really important that when you're generating your toolpath, that you check to see, has it gone where you think it's going to cut? And if the surfaces are shaded, you can't see where that toolpath is. Did it go around or through that surface? So if you click S on your keyboard, you can toggle the shading on and off of the surfaces so you can see exactly what's going on. So that's a great tip there, Brian. Thank you for asking. Hopefully that answered that question for you. All right, good. Let's see what else we got. So we got Z-level rough. This is our pocket routine. Okay. Let's go ahead and add a Z-level finish here. So we'll reselect our geometry, and then we are going to compute our toolpath. All right. Z-level finish. This is the lighter blue. This one's for more vertical walls. This is like a 2D profile. It's for more vertical walls. It's going to follow the contour of the surfaces that you selected like you were profiling, except it's going to follow the surfaces. So if there's a tape or an angle, it's going to follow along them. Now, one of the things that you'll notice as the surface starts to flatten out, if we look at the bottom valley of this here, as the surface starts to flatten out, you're not getting any toolpath coming along these surfaces. And if you look as it starts to flatten out, you can see the scallop starts to get larger and larger. And that's because Z-level finish is best used for more vertical walls. And as the surface, or steep walls, as the surfaces start to get shallow, you're going to start to get greater and greater scallops. Okay? All right, so that's a little bit about Z-level finish. Let's go ahead and blank that guy out here. The last one we want to talk about here is planar. Okay, planar a lot of times is your go-to toolpath. This is going to move back and forth along an angle. Now, if we look at this example here, you can see I have it cutting on a 45-degree angle. All right. If you can see I have planar 1 and I have planar 2. If I compute planar 2, you can see that's cutting at, one's a 45, one's a negative 45, so they crisscross. The reason why I do this is it gives you really good coverage. If you're a pattern maker or you're working with softer materials, or you want to just get a good coverage on these different surfaces along these areas here, you can run a crisscross and it will do a really good job cleaning it up. It also can be used to put textures and different patterns on your part. It's a really popular way to machine. People have been doing it this way a really long time. So, but if we look at planar, okay, let me blank one of these out. You're going to see planar is going to do really good on the shallow areas of the part. So on the flat down here, and then also on these flat surfaces here, you can see that we're getting really good coverage. But as we start getting into the more vertical areas of the part, this is where we're going to start to see more scallops. Now, again, I'm cutting this on a 45 degree. If we look at this as we progress through it, here, let me get out of that again. Right-click, backplot. As we look at how this progresses through this, you can see that it's working across the part on a 45. So it's going up and down the hill across the part. Now, with planar, you do have the ability to adjust the angle of the toolpath. So right now I have it as a 45. That's one of the parameters settings for it. So you can adjust that to run down the length or run across or run at an angle. Again, it's just going to work back and forth, and where it does really good is more shallow areas. Where it's more vertical, it will leave more of a scallop. Now, I have a bunch of samples to run this through. Some are going to be more evident than others, but again, these are the three most common strategies. So we have Z-level rough to pocket out the material. We have Z-level finish to cut the more vertical areas of the wall, and then we have planar to cut the shallow areas of the wall. Now, one of the things that I want to do here one of the things that you're noticing is when I blank these toolpaths out, if I'm not clicking on the toolpath, or if I'm not highlighted on that toolpath, let me see, let's turn this one off too. Okay, right click blank. If I'm not on that operation, then it doesn't display. But if I click on that operation, it does display. So this is a very important tool that gives you the ability to isolate the toolpath that you're looking at. You don't want to look at all of these at the same time. If I go to this and I unblank or blank them all, if they're all on the same time, it's really hard to tell what's going on here. So that can be really frustrating, especially for newer users. So what you want to do is be able to blank and unblank them so you can see them when you want. Now, in this case, I'm using a folder or a group in the tree so I can group these features together. If I right-click on that folder, I can go to blank unblank toolpath, so that will hide everything that's in the folder. Now if I click on one of the individual operations, you can see just that toolpath is displayed. And I do recommend you adopt this as part of your workflow because it will make viewing what's going on quite a bit easier. Now, what I'm going to do here is I'm going to look a little bit about Z-Level Rough real quick, and I'm just going to make one adjustment on each of the strategies and see what happens. And again, this is how I recommend new users or even experienced users to get familiar with new toolpaths. There's lots of options, so you want to just edit one thing at a time. One of the things you'll notice is this toolpath is actually starting right along the edge of the wall, and that's one of the common questions that come up. You know, how do you control where the toolpath starts and where it ends? And again, depending on the strategy you're using and whether it's standard or pro or advanced will determine the control that you do have. In this case, really what I want to do is I want to try to get this tool away from the wall here. Now, so if we go into this, this strategy and we want to edit it, so we're going to go to the feature name and right click and choose edit. This will get me back into all the different settings that are for this toolpath, okay? So I can go to my patterns, and right now I have it set to pattern in, which means it would start on the outside and work its way in. And that's really what we're seeing is the tool starting on the outside and then it's working its way in. What we want to do is switch this to pocket out. That way it will start on the center and work its way out. Okay, so we make our adjustment, then we're going to recompute that feature. We'll click back on it, and then now we can see instead of the tool starting on the edge of the part, you can see that it's starting in the center of the part and then works its way out. Okay, so you want to experiment with the different features and the options, change one thing at a time and see what happens. Okay, so that's Z-Level Rough. Let's look at Z-Level Finish. We're going to go ahead and right click on the feature name and choose edit, and then we can look at, you know, you have patterns, you have parameters, you have leads, you have options, okay, and you have links. These are different options that we have. Now right now in this example on the links option, it's set to follow. So as it does a step down, what happens is it follows along this wall, okay? So what we're going to do is we're going to change this one to retrack, which means it will go up, go over, and come back down. So we're going to change our setting. We're going to choose finish. We'll come back to the feature here and compute, or we could have computed from the wizard, and you can see the difference here. Now we have a lead in and lead out on every profile versus having it step down and following along the wall. So if you change one thing at a time, you can see what happens. If you like the change that you made, you can keep it. If you don't like it, you can go back and edit it. Right click on the feature, choose edit, okay? This time it was links. Maybe we want to set it to a spiral. We'll go ahead and compute, and then now you can see that that toolpath is going to spiral as it links from one level to the next, okay? All right, so that's a little bit about Z-Level Finish there. We're going to go back to Planar, right-click, edit. All right, in this one, we're going to just look at patterns, okay? So you have single direction cutting and bidirectional cutting. If we change it to single direction, we're going to cut in one direction, then we're going to wrap it back to the start, and cut in one direction and wrap it back to the start. So let's make that adjustment. Now, in this case, I have two different cutting strategies. I have Planar 1 and Planar 2. So if I hit compute from the wizard here, what's going to happen is it's going to compute both strategies. So I don't want to do that. What I want to do is I just want to compute the first strategy, okay? So we're going to go ahead and choose Finish. I'm going to right-click on this feature here, excuse me, this operation. I'm going to hit Compute. And what you're going to see is, I didn't pick the setting I wanted, so let me go back, set it to zig, finish, right-click, compute, and then now you can see that it cuts in one direction and rapids back, and cuts in one direction and rapids back, okay? It looks like we have another question here. Let's see, how do I, let me get this. Let me get this separated. All right, there we go. All right. Okay, so there was another question here. Let's see. Is there a quick sheet of all the hotkeys on BobCAD software? JC. Hey, John. Thanks for asking a question there. Give me just a second, guys. All right. So one of the questions was here: is there a list of all the hotkeys of the BobCAD software? I don't know if it's listed on the website, but if you do go to Preferences and you go to Shortcuts, this is going to show all the different options you can use for a shortcut, and then you can go to each one here, and if there is a hotkey created already, it will show what that shortcut is. Okay, so this way you can go through and you can see what shortcuts are already set up and which ones you want to use. You can reset them, you can create your own. Okay, so hopefully that answers that question there. Okay. John asked, what's the reason for Planar 2? Planar 2 cuts against the direction. One was set at 45 and one was set at minus 45, so that way we get good coverage. They go back and forth, okay? Thanks, John. So again, we made an adjustment. What we did is we changed this from zig to zigzag. So now from zigzag to zig, so now you can see it's cutting in a single direction. It works its way across, and then it comes back to the start. We can kind of see what's happening here. So you can use this single direction cutting for uphill cutting or downhill cutting. This way you can control that it's just climb milling the whole time, or it's just cutting up the whole time. All right. So again, when you're making changes to your toolpath features, when you're making changes to your toolpath features, you want to do one at a time and then update them. Okay. So the key takeaways here, the first one is you can blank and unblank your toolpaths. This way you can just see one operation at a time, okay? The other thing is, in order to make a change to the toolpath, you have to right-click on the feature name and choose Edit. That will get you back into the wizard. In order to update for the changes, you're going to right-click and hit Compute, and that is going to update for the changes that were made, okay? Now, the next thing that we want to talk about here is really reusing the strategies that we have. And you have save and load. You can click on any feature and right-click and save it. You can save it to directory. You can also click on any feature and right-click and choose load, and then you can load it into the CAM tree. So that's one way that you can save your features and be able to use them in the future. Another thing you can do too when you have multiple features in the tree with multiple operations is you can take an operation from one feature, you can copy, and you can paste it into another feature, okay? So you can right-click, copy, right-click, paste, okay? Right-click, copy, right-click, paste. So now this one feature here has the Z-level rough, it also has the Z-level finish, and it also has the planar. Okay, so you can copy and paste between features, or you can copy and paste the entire feature. You can copy and you can paste. Okay, so this way you can reuse your information from one job to the next. I'm going to go ahead and delete all these here, and then we'll go back up to the top here where I already have them. Now, a question that came up in last week's webinar was what information is saved and what information is not saved. If we edit our feature here, okay, your top of feature, I believe, is not saved. So if you have a top of feature at the bottom of the part, or if this setting here is different, this is not going to carry over, I believe. But what will carry over are things like your patterns, parameters, depth of cut, stock for finish, allowance, leads, and options. Okay, so all that information is going to carry over. When it comes to your tool, if you uncheck use system speeds and feeds, your speeds and feeds would also be carried over with that feature. Okay, so your speeds and feeds can be saved to your feature. Your tooling information, if you uncheck system tool, your system tool information can also be carried over. Now there are some strategies that you want to use with your tool crib, loading a tool crib and calling tools from a tool crib when you're dealing with tool numbering. There's also with save and load for different cycles, like drilling cycles. There are some different variances as far as what's saved and what you will load. So when you're dealing with just specifically on these three strategies here, your tooling information, if you uncheck system tool, that should come over right away, but I would really want to talk about using a tool crib and loading that tool crib prior to loading a feature in that uses a tool number. Okay, speeds and feeds, if you uncheck use system speeds and feeds, these are going to come across, and all of the other settings, when you save that feature or copy and paste them, they're all going to be defaulted. So those are going to be the settings that are going to be used there. Okay, now I have this 3-axis feature here. I'm going to go ahead and right click on geometry, reselect, select all, and then spacebar. Okay, so I'm using select all in this example. One of the things that I want you guys to be familiar with is when you go to select, you can also choose pick by color, and you can choose pick by layer. And I believe part of the CAD process is working with layers and colors to select your geometry. It's really important. As far as one of the stages, geometry preparation, is to put things on different layers and colors, so it makes it easier for you to select things when you get into the machining processes. Okay, so we're going to just use all. Now I also use my space bar as a right click OK. That's kind of a shortcut. You can also right click and choose OK, or you can hit your space bar to lock in your selection. Okay. All right, so real quick, someone asked, can you save a feature to a USB? Yes, John, you can save a feature to a USB. You could save it to your local drive. You could save it to your network drive. If you have a floppy drive, you could even save it to that. So wherever you want to save it, you can save it. Okay, John? All right, so we've selected our geometry here. We've computed our Z-level rough. Now, again, you can go down the tree here to these individual operations. You can right-click and compute, and it will compute them separately. If you want to update them all, you can go to the top feature and choose compute all, and then that will compute all those toolpaths. All right, so again, if you make a change, you need to recompute to update them. All right, so let's remove here and recompute just to get rid of everything, or reset our toolpath. Now, so I think at this point we have a good idea of the different strategies: Z-level rough, Z-level finish, and planar. Just real quick, by a raise of hands, is there any questions about Z-level rough, Z-level finish, and planar, just as a fundamental understanding of what that toolpath is? If you understand Z-level rough is for pockets, Z-level finish is for profiles and more vertical, and planar is for shallow areas, just raise your hand in the meeting. Just go ahead and do that, just so I can see that we're all following along and that this is pretty clear. Okay, and if you have any questions, just type it in the question box. There's no any question, all questions, they're all good. I want to get through all the questions that are there, so if there are any questions, feel free to ask them. Okay, so it looks like most of you guys are on page here, we're on the same page here. Okay, so let's look at geometry selection. Okay, so when it comes to geometry, what can you use 3D toolpaths on, right? Well, the first thing I'm going to do is I'm going to just go to the wireframe. This is the wireframe that I used to create this, this model here. If I select this wireframe and I try to compute these toolpaths, nothing's going to happen, because 3D cutting strategies are based on surfaces and solids. It's not based on wireframe, okay? So the first thing to know is that you need surfaces and solids in order to generate your toolpath, okay? Now, so what happens if we select just a single surface? So I'm going to just select this surface here, and I'm going to compute my Z-level rough. Now, if you look at this, we're getting some toolpath generated here, and that's probably strange looking. You know, this toolpath is being generated. This is the surface we've selected, and you can see this toolpath is extending out. The reason why this is happening for Z-level rough, and actually I want to go in here real quick. Let's do pocket out, finish. All right, so the reason why this is happening with Z-level rough is because Z-level rough uses the stock as a boundary, okay? So when you run your stock wizard and you define the stock geometry that you're working with, that is what the software is looking at. So if let's edit the stock here, and let's extend the stock out in X. Let's go 3 inches out in X, okay? So now we're saying there's additional stock on the side over here. If we recompute our Z-level rough, you're going to see the toolpath is going to go over to that area. Now, this is the only surface that we selected. Let me change the transparency here. This is the only surface that we selected, this one here, but the Z-level rough uses the stock as a boundary. Now, the other thing to understand, too, is for the boundaries with the mill standard, the tool center goes to that boundary, okay? So if let's bring this out to the outside edge here, right? You can see the tool center is going to this boundary, okay? So when you're using boundaries for Z-level rough, Z-level finish, and planar, the tool center is going to that boundary. That's an important thing to understand. It's also important to understand that with Z-level rough, your stock is part of your boundary, okay? Now, let's say we didn't want the tool to go out here, right? What are some of the things that we could do? Well, we can add a boundary. Now, you have a boundary, just like you have the main geometry, you have a boundary, like a parent boundary, and that would be applied to all the features that are below, or all the operations, excuse me, that are below, okay? So BobCAD is a feature-based CAM system. This is your feature. The feature is based off of a category. It's associated to geometry, and it contains operations. The operations in this example would be the cutting strategies, okay? So for this feature, this is the geometry that we're working with, and then this would be the parent boundary that would be applied to all of these different cutting strategies. So if I select just this single surface here, and I recompute my Z-level rough, you can see I'm going to get no toolpath, okay? One of the reasons why I'm going to get no toolpath is there's no stock on top of the part, okay? So there's nowhere to cut there. If we go to our Z-level finish and we compute that, you can see that the best that I can tell here is it's a little confused. It looks like it's just cutting this side here. If we look at our planar and compute it, you can see the planar is just going over the top of that edge. If we do the planar in the other direction, you can see it goes in the other direction, okay? Now here's the thing. I did select a surface there for the boundary. For a single surface boundary, if there's a surface that you can select, that will work. If you get into multiple surfaces, not always the best option. Most of the time what I use for these is I would use a, most of the time for these what I would do is I would use wireframe. A lot of times I'll use wireframe. When I go to select the boundary though, I can right click, reselect, and I can pick edges off the model. And this is another good time to use the shading to turn it on and off, okay? All right, so what are we talking about? We're talking about geometry selection and how that is important to your toolpath, okay? So let me go back to my stock here, and let me just zero this so that it's not extending off the part, all right? So let's go ahead and do our geometry selection here, and let's select these surfaces down at the bottom of our part here. So we'll select those, we'll hit spacebar. We're going to go ahead and compute here, And what we're going to see is that the toolpath is being driven along these surfaces here, and it's extending out to the stock boundary, right? That's what we expected. Now, the other thing that we're finding here too is that, well, let's see here. So one of the points that we're talking about is the toolpath is driven based on the surfaces that you've selected, okay? We've selected these surfaces down on the bottom of the part here. Let me blank this out. These are the surfaces that we selected here with the Z-level rough. It runs all the way out to the stock boundary. Let's look at the Z-level finish, compute, right? We're getting very little toolpath here, but we really wouldn't expect any because Z-level finish is really not best suited for the shallow areas of the part. If we go to planar and recompute, we can see the planar toolpath does a good job there going back and forth, but we would need to pay attention to our neighboring surfaces. If you look at this here, you know, when this tool is coming down, the center of the tool is going to be driven to the boundary. In this case, the boundary would be the edge of the surface, okay? If we were to reselect, let's say remove, reselect, and we select, let's say this surface here, and we recompute this, the Z-level rough is going to follow that surface and trim out to the stock boundary as we expected. The Z-level finish is going to machine the best that we can, and it's trimming back here, so that's doing what we would expect it to do. The planar here is coming along as well, but what you're going to see is as this planar comes into the edge of the part here, because the center of the tool, you know, it's being driven on this, you can see that this tool is actually running into that neighboring surface, okay? So the tool's running into this neighboring surface because we only selected one surface there, okay? So the geometry that you select plays a huge role in how this toolpath is created, okay? If we go ahead and we select some additional surfaces and we recompute, again, what we're expecting to see, you know, we have an understanding of why we're getting that toolpath and why it's there. A lot of times for new users, what I recommend when you're selecting is just to select everything, because only the surfaces that you select are considered with the gouge protection and with the toolpath. So you're gonna get a more consistent result with your toolpath when you've selected everything versus when you try to pick off individual surfaces. When you try to pick off individual surfaces, generally that's where you're gonna run into you know, the tool making contact with other areas of the part, okay? Now, some of the things we talked about as far as like boundary control, you know, we did pick a single surface there. We could, you know, like I said, you can try, like if you pick multiple surfaces as a boundary, that's what I'm doing right now, the result is generally not what you're expecting it to be. I mean, it's very inconsistent as far as the results that you're getting. So if you're trying to select surfaces as a boundary and you're using multiple surfaces, I really just don't recommend it, okay? What I generally recommend is wireframe as a boundary, or surface edges. If we come through here and we pick these surface edges, let's say we only want it to look at in this area here, right? Okay, and we recompute that. Now you can see using those surface edges, we can contain it in that area there. We can compute the Z-level finish here. The Z-level finish, again, is following this boundary too. There's a boundary here. I was wondering why it kept going to an area that was not what I expected it to be. It was this boundary. Let's remove that. So now we'll use the parent boundary. Okay, so each of these features have their own boundary, so you can use different boundaries for the different operations. But once you've set a parent boundary, then it will default to that one unless it has its own boundary. Okay, so if we recompute this here, now you can see it's cutting back to that side. The planar here, now you can see it's cutting to that side. Okay, now with the planar, we could do what we could do with the planar if we wanted it to go uphill, right? Instead of 0 degrees, or it'd probably be a good idea to throw it at 0 first and run zig. We'll finish this and recompute that. So 0 degrees is going in this direction, but is it going left to right or right to left? That's where this backplot really comes in handy, so you can see it's going 0 degrees, okay? You can see which direction it's going in, all right? It also, by doing it this way, it really makes it more clear how the shallow areas of the part it does a good job on, but the more vertical areas of the part, you know, as this gets steeper, you can see the scallop gets greater and greater, okay? So in this example, if we wanted to run up this surface here, right, let's go ahead and change our cutting boundary, or I'm sorry, our, wrong one. Let's go to here, parameters. Instead of 0, we're going to make it 90. We'll recompute. We're going to go ahead and backplot. So now we can see how this is going to start at the bottom, and then it's going to work its way up, okay? So this gives us the ability to go up in that direction, and you can play this over so it rapids back and it's going up and going up and going up, okay? All right, and we have a radius lead in and a radius lead out. So that's what we have going on there. So that's a little bit about, you know, we're selecting the whole model, we're using a boundary to contain where that toolpath is going. We use Z-level rough to remove the bulk of the material. We use Z-level finish for the more vertical areas of the part, and we use planar for the more shallow areas of the part. Okay, so the next thing that I want to talk about here has to do with top and bottom of job. Okay, so if we edit this feature here and we look under parameters, you're going to see depth options, top of job and bottom of job. Okay, so each of these machining operations or cutting strategies or toolpaths, they are offering top and bottom of job parameters, top and bottom of job. Okay, and what this allows you to do is control where it's going to start cutting and then where it's going to end cutting. Okay, so if we look at our parameters for our Z-level finish, this is best for the more vertical areas of the part. So when we go to top of job, we can say, okay, start from wherever it's at, but bottom of job, we can limit it. We can say only go down so far. So you can enter this value, okay, or you can pick it off the model. And I do recommend working with the pick it off the model because it kind of tells you where that measurement is from that edge, and then you can adjust it up or down as you go from there. So we set this to go to minus ½ inch. We recompute that, and now you can see that it's staying just in this direction. Now, another thing too that you'll notice here is that if we rough this out, you know, in this section, in this Z-level finish, what it's doing is it's following back here. You do have other options as far as what happens to it. If we look at Z-level finish on the links and we go link on boundary, you have follow, which is what it's doing right now, and you also have retract. If we set this to retract and we recompute that, now you can see it's just cutting, rapiding back, cutting, rapiding back, cutting, rapiding back, okay? So, you know, again, each of these strategies have different options, and as you get familiar with the different options, you know, you can start fine-tuning your toolpath better and better. Bear with me just a second, guys. All right, sorry about that, guys. So, all right, so linking on boundary with Z-level finish, you have follow and retract, and again, depending on what you're working with, one may make more sense than the other one. We're going to set it to retract in this example. We'll go ahead and recompute, and you can see now we're just cutting in one direction, okay? If we want to, well, I assume that it's going from right to left. Let me backplot it, and now I can see for sure, okay? So again, we're using top and bottom of job to control where we're cutting. We're saying, you know, only go down to a certain depth. If we go to the planar here, so we can go planar, we can do parameters, top of job. We can go ahead and change this value as well. We can say pick and pick off the model. You know, maybe we want to do, you know, set this value here. Maybe we want some overlap, so we'll make it a little more shallow. We'll choose finish, come back and compute. You know, now you can see, I messed something up for sure. Now you can see that, you know, you can control where it starts cutting and where it ends cutting. So let me go back in there. We'll go to planar. I'm sorry, it's top of job is what I want to set, and I want to pick that to here, All right, we can add our overlap, finish, and compute. You know, now you can see that we're controlling where it's cutting. And again, this one's set in a single direction. So it starts at the bottom, you know, and then it just works its way up that radius, and then it comes back off of it. Okay. All right. So you got rough, finish. Again, we're using top and bottom of job to control where we're going to start cutting and where we're going to end cutting. Now, what I want to do is I want to run this through simulation. All right. So in simulation here, we're going to do, let's do next stop. That will get through the Z-level rough. We're going to do, we'll slow this down. This is the Z-level finish here. You know, so it's working across the part down to a certain level. And then this one here, this is the planar. And you can see what the planar is doing is working its way from the center, working its way up and back. Now, we didn't clear out this whole channel here. So let's look at doing a couple of things here. So what I'm going to do, I have the whole model selected. I have a boundary here. What I'm going to do is remove this boundary, recompute. So now I have the whole cavity being cut. I'm going to go to my Z-level finish. There's no boundary here, so I'm going to recompute that. Okay, so now in this example, you can see how it's cutting around the outside of the part. So that's really not going to work for me, right? So I'm going to come back in and reselect. Again, I'm going to pick around these edges, so I want to keep it inside of this cavity. I don't want it going around the outside. So I'm just picking these edges. Again, you can toggle the shading on and off with your S on your keyboard. Okay, there we go. Space bar to lock it in. So that gives me my boundary there, and I compute that. So now this is going to go ahead and cut the more vertical areas. Then we have our planar here, right? So we have our planar here. The planar, what I'm going to do with this one is I'm going to go from here to here to here. Those are the surfaces that I'm going to select for my boundary. I'm going to recompute, and you can see that those are cutting in that direction. That's fine, okay? So now on this planar here, I'm going to select the other side. So I'm going to go here, here, and here, all right? I'm going to edit this, and then this one is set to 90 degrees. So this one I'm going to set to 270, right? And then I'll compute that. Okay, and then let me set that to single direction too. So I'll set that to single direction. All right, so now let's go ahead and run this through simulation. All right, so I'm just going to next through the first operation of roughing this out. Okay, this one here, this is going to be our Z-level finish. So this is catching the more vertical area of the part. And then this one here is doing the uphill machining from the one side. And then when it gets done on that side, it should switch. And then this one's doing the uphill machining on the other side. I don't have my top of job set on this one, so you can see it's rolling all the way up. But what I'm showing you here is how you can combine cutting strategies and use boundaries to target where you want to cut your part. Okay, so you can get pretty creative with it. Again, generally I don't recommend selecting the surfaces as a boundary. You can run into problems with that. Usually I would go to wireframe, but you can see here that it can be done. Let me go ahead and edit this. Again, I want to change my top of job. This is going to be 45. We're going to finish and compute. And that shows a little bit of what we have going on there. So now we have consistency. Same on this side as this side. We have our Z-level finish, and then we have our Z-level rough. Okay? Now, one of the other things that I wanted to talk about here is using additional surfaces. How do you use additional surfaces to control your toolpath? And there's a lot of different ways that you can do this. One of the more common things that come in is getting the tool to start and finish off the surfaces. Okay, so the way that you accomplish that is you add additional surfaces. So for me in this example, I'm going to do solid, extrude, I'll just do extrude surface here. Okay, I'm going to select on this surface, and then I'm going to, add some additional surfaces here. So I'm going to make this, maybe a 1/4 inch out. We'll do that on that side. I'm going to go over to this side. I'm going to make it a 1/4 inch out on that side. Okay, so now I've added some additional surfaces. So when I get into my machining, and I'm driving my toolpath along those surfaces, it will change where that toolpath is driven. Now I do have some boundaries in here, so I would need to update those boundaries. But you get what I'm doing here by adding those additional surfaces. I can have the tool, extend past the edge of the part. And that's really what the idea here is, to be able to have it extend past the edge so you can get it to machine past the edge of the part. All right, so there are some other examples of using surfaces, not only to drive the toolpath past the edge of the part, but also to use surfaces to stop the toolpath from going down into different areas, okay? So let me jump to the questions here real quick. When you do set your Z-level rapid plane between moves, and where do you set your Z-level rapid plane between moves and operations? Well, when you look at the feature here, there's clearance plane, rapid plane, feed plane. The rapid plane is above your top of job, so that's where your rapid plane is set. The clearance plane is where the tool goes to at the beginning and ends of cuts and between groups of geometry. Like if you have one boss over here and you have another boss over there, that's kind of your jumping location. So that's where those are set. Let's see here, what else we have. This works. Older machines. Steve, that's really a posting question. We'll have to jump back to that on another time. You can use boundaries and add lines and stuff, John, but that when you're dealing with boundaries outside of the part, and we're going to get into that here in just a second. So at this point, what I'm going to do, we talked about geometry selection, the importance of how that affects where your toolpath is being driven, boundary control, how you use a boundary to control where your toolpath is being generated, and then we have top and bottom of job, how we can control the levels, where it starts cutting and where it would end cutting. The other thing that we're talking about is keeping the tool away from areas. You'll use boundaries in order to do that, or surfaces. Stopping the tool from going any deeper or having it cut deeper, you use top and bottom of job. And then extending toolpaths past the edge, you can use additional surfaces, but there are other methods that we can use as well. All right, so let's see here. What I want to do now that we've set this job up here, let me close this file out. Let me see here. I want to look at some of these cutting strategies that we have here and applying them to different jobs. So I'm going to load this guy back in, which is fine. I'm going to drop another file here. Let's see. Let's go with 2. Let's try 3. Okay, here's 3. So this one is a similar type scenario where, we have this this surface here. It's curved on the top and we have some radiuses. We're going to go to our cutting strategy here. We're going to copy, go to this file. We're going to paste it. So we're pasting in our machining feature with all of our operations. We're going to select all our geometry. And then what we're going to do is we're going to compute our Z-level rough. So again, like we talked about, the Z-level rough is trimmed to the boundary. And this is probably one of the most common things that I run into with Z-level rough and talking about how do you get your toolpath to go around the part. So in this example, we could use a boundary. You could you could sketch out a boundary further away from the part, and then you could select that boundary as part of your feature, and then it will compute it out to the boundary. That's one way to do it. Another way to do it would be to adjust the stock, right? So let me blank all these guys up. So if we're looking at the Z-level rough, if we want it to extend out, we can go to our stock wizard. We can go in here and we can extend stock on all sides, even on the bottom. Once we update where our stock is, if we recompute this feature, now you're going to see that the toolpath is cutting out to where the stock is, okay? So that's one way that we can do this. Let's go back and just zero this out here. All right, so we have our Z-level rough. That's going to remove the bulk of the material. We have our Z-level finish. This is going to be for the more vertical walls. What you're going to see is where it's really shallow on the top. We're really not getting the best finish there. We can go to planar. Planar is going to come in here and clean up the top of the surface, and then we have planar in another direction. So when we were on the inside work, you could see the toolpath was cutting where we wanted it to cut to with planar. When we're on the outside work, you can see that it's stopping at the edge. So let's look at this feature here, and we'll go to our options. So the options for planar is either extents or it's part bottom. All right. So what we want to do is change this to part bottom and choose finish, and we'll recompute our planar. And now you can see that the toolpath is going all the way down to the bottom of the part. All right. So again, each of the different cutting strategies has different options. Getting familiar with them. You have cutting extents for planar. If you have it set to extents, it rolls over past the edge. Not quite the tangency, but it does roll over past the edge. Or if you set it to part bottom, then it's going to go all the way down to the bottom of the part. So in this example here, we roughed it out. We have our Z-level finish. You know, Z-level finish is better for the more vertical areas of the part. So what are we going to do? We're going to come in here. We're going to go to our parameters, top of job, pick. We're going to pick right below that radius. We're going to choose finish. We'll go ahead and compute that. And now you can see that that one's starting further down. Now, if we want to have it extend down even further, we should be able to go, let's go to Z-level finish. We'll go to parameters, bottom of job, pick. We can pick up the bottom. So let's make it minus 1.375. Okay, we should see that this will continue down based on the level that we tell it to go to. Okay, so you can not only control where it starts cutting, but you can control where it ends cutting as well. Same thing with the planar here. We have it going to part bottom. That's not really where we want it to go to. We can go to planar. We're going to say bottom of job, pick. We're going to pick that radius point again, finish, and compute. And now you can see we can get it to cut past that. So we have our rough to rough it out. We have our Z-level finish to work on the more vertical walls, and then we have our planar to clean up the top. So let's go ahead and launch this through simulation. We'll take a look at what we have going on here. I'm just going to skip ahead to the next operation. Okay, so we got our material roughed out. We're going to slow this down. We'll run this through. You can see this is going to cut the more vertical area of the part, working its way down. Once this one gets done, we'll come back with our planar, and we're going to step back and forth, okay? Speed that up a little bit. Maybe hide the toolpath. And there we go. You can see we get a nice finish on the part. This also has the planar going the other way. Sometimes that's necessary. Sometimes it isn't. Again, it depends on your material. But you can see how we're combining the top and bottom of job, where we're starting and where we're ending. All of this is coming together, okay? All right, so what I want to do from here is I want to talk about some other samples. Let's look at some other samples here. Let me get into the zone. All right, so what do we want to look at? I want to look at this part here. This is a common scenario that comes up as well. This is when you have a surface and you have some holes in your surface, right? So now keep in mind, when you're doing your 3D machining, you can utilize 2D toolpaths as well. You can combine both 2D and 3D toolpaths. So here we have this, this curved surface. If we look at it from a front view, or let's say a right view, you can see there's this curved surface, but you can see there's these cutout holes in it, right? So let's go to our cutting strategy. We're going to grab our feature, copy. This one I got to run the stock wizard on, so let me set it up real quick. That's fine. We'll go ahead and paste our feature in here. We're going to select our geometry. This one we're going to look at planar. So when we compute our planar, one of the things that you're going to see is as this tool runs along the part here, it's ending up dropping down into these surfaces. You can see how it's dropping down into that area of the part. And you may not want the tool to drop down in there, you know? You really may not. So what can you do to control that? Now, in the feature, there is an option that says ignore holes. Okay, so you can click on ignore holes and choose finish and recompute. And see, the thing is, sometimes this works and sometimes this doesn't work. It depends on the geometry that was used to create that. But you can see how with the ignore holes, the tool is kind of running up over it. But I don't know, we would kind of want it to go past that edge there. That really is not the ideal scenario for us in this example. If you see with the ignore holes on this part here, that's actually leaving toolpath there, and then when you factor in the radius of the cutter, you know, not the most ideal scenario. So what are some of the other things you can do? Well, some of the things you can do are based on design. I don't spend a lot of time on design in this webinar, but design is part of it because the surfaces that you're selecting play a huge role in how your toolpath is being created. So in this example, I used an extrude cut for these. So I could just suppress those features and then reselect my geometry and then recompute my toolpath, and you'll see now that toolpath is running right across the part. Okay, so I could suppress the features, but what happens if you didn't design it in BobCAD? Let's say that you imported it, which is very common, that you're importing from another package. So what do you do then? Well, what you do then is you go to your wireframe, and again, I'm not going to spend a lot of time on this, but what you can do is you can generate cap surfaces. There's a bunch of different ways to do this. You generally will convert edges, so you'll extract to wireframe. This will give you all that wireframe geometry. From here you can do like a planar surface, and then this will cap over that. Now these curves are, sometimes it's not as easy as just doing this, but even with these, it's still going to put flat areas on the part. Okay, if we remove and reselect, we add those in, and then we compute again, you're still going to see that's kind of what happens with the ignore holes. We're in a similar scenario. Okay, so another thing that you may do is you may untrim a surface, and that's, again, without spending too much time on this, what you can do is go to stitching, unstitch your model, break it down the surfaces, then you can do surface, and you can, let me see here, other, where is it, surface, untrim surface, select that, and then that will basically cap those holes off for you. That's another way to come at it here. Let me see. Yeah, and then now those holes are filled in because you're driving off the original surface. So that's another way to come at this. So this is a really common scenario that comes up. Another way that I might do that, again, with the CAD features, may be based off of, you know, this wireframe. A lot of times if you have a full circle like that, I'll break that circle into two. You know, so now you have one section here and one section there, and then I'll do something like a cross section surface. So it'll go from here to here and there to there, and then that will give us a more along the curvature of that surface plane. So that's another one that comes up, is when you're dealing with holes like that. Another example here has to do with you know, like a Z-level finish. Let me run this through the stock wizard. All right, so we got this going on. We're gonna paste our feature over. We'll select our geometry here. Okay, what I'm going to do is I'm going to create a layer. This is going to be for my boundary. So extract edge is single, project to Z 0. We're going to pick this face here. Okay, so what we have is a boundary and we have a surface that we want to work with. We have all of our geometry selected. We have our Z-level finish. We're going to select our boundary here and we're going to compute. And see what's happening here is that the tool, when we look at this, you know, and you might be, this example I believe was dealing with a bull nose, but when it gets down here to the bottom, you're going to see that it just doesn't quite get all the way down to this bottom edge here. And again, this is based off the boundary. That's what's going on here, is the boundary isn't giving, you know, the tool enough room to get down to this intersection. Okay, so what you would need to do there is you would need to edit your boundary. Okay, there's a lot of ways to edit your boundary. One of the ways to edit your boundary would be to stretch your geometry. So you could go to stretch. We can do multiple entities. We can do a delta. Select these guys here. We'll do minus a 1/4 inch or more. What that will do is give the tool room to get down inside of there. So when we reselect our boundary here and we recompute, again, the tool, that's the wrong one. The tool center goes to that boundary. So that will give it the additional room that it needs in order to get down to that intersection. Okay, so that's another popular question that comes up as far as how to get the tool to cut where you want it to cut. A lot of times you'll need to extend your boundary because based off your boundary and your geometry, there isn't enough room for the tool because the tool center is being driven by that boundary. Okay, so that's another good one for you. You know, when we get into cones, things like this, again, we'll run this through the stock wizard. We'll set our 0. We're going to go ahead and paste our feature into the tree, select all our geometry, compute our Z-level rough. That's going to give us a rough to rough out the material. Compute our Z-level finish. That's going to give us a waterline type routine. It's going to cascade, so we'll select this inside curve here and compute. So between those two, we've done pretty good. Planar we really wouldn't use on a conical shape like this, and then in order to finish this bottom surface here, we'd come in and do like a pocket, you know. You could come in, if we wanted to finish off this bottom surface here, we could load like a 2-axis routine, select that face, pick that edge as our bottom, machining strategy, pocket, you know, and this one here we'll do something like a spiral. And then compute that. So that will give me a finish on that bottom face. So we have the face finished on the bottom, Z-level finish for the walls, Z-level rough to rough it out. Now your step down for your Z-level finish, depending on the tool that you're using, you know, you can tighten that up so you get a nice consistent finish in there. Okay, so that's a little bit about like conical type cavities. This dish here, this one here, you know, this is a pretty shallow surface here. So when you're doing Z-level finish, this is where you run into some issues. Now, you could use Z-level finish and step it down. You could use planar to cut back and forth across it, but there are, when you're dealing with more round shapes like this, in this type of fashion, there are other strategies. You may go with a radial, you may go with a spiral. Those would be some of the options that you have with Mill Standard. When you get into Mill Pro, you may use project curves, you may use equidistant offset. Okay, so each of the strategies have strengths and weaknesses, and learning how to kind of apply them together is a little bit of an art. Let's see this, we got a stack up here. This is another good example of using surfaces to block where your toolpath goes. Okay, so we're going to do another job here. We're going to paste our feature. We're going to select all our geometry. Let's do our planar. Okay, our planar is going back and forth over this model. Let's see if I have my depth settings here. No, probably doesn't fit down inside of there. Now, if I wanted to stop the toolpath from going any deeper than this surface here, okay? I can add another surface to my selection. Now when you do that, the toolpath will be driven along that surface, but it won't go down inside of that hole. That's another way that you can use to block areas of the toolpath. You can block where you're going and where you're not going, okay? So let's see here. I mean, it's 2:15 now, so we're running a little late, but I think we're doing all right. This is another really good good example. Let me see here. This one has to do with fill surfaces, or what I would call a fill surface, where you want to block the toolpath from going down into an area. So if we select all this and we do our Z-level finish and compute this, let's change our tooling a little bit. We'll drop this down. We'll go something like this. Let me get rid of the lead for now. Let's go vertical. All right, so here you can see the toolpath is running around the outside, but it's also running around the inside. You do have some options within the feature. Let me just change this step down so we get a little tighter finish here. So you do have some options within the feature in order to control inside cutting and outside cutting. If we go to options, we have all, we can say outermost and recompute. Now you can see that's just going to switch from cutting inside and outside to just cutting outside. So it's really just going through each feature and kind of spending a little more time with it. Let's see if there's anything else that I want to cover here today. I think this is probably pretty good webinar. See if there's any questions that I haven't covered. We set our rapid plane at the feature level. Hopefully that answers that. What is the reasoning for planar? It just goes back and forth. It's a good area coverage. You can definitely use boundaries to contain your toolpath. When it comes to G-codes in your post-processor, Steve, the best bet is to email support@bobcad.com, and any questions that you have, they'll be able to help you out with that. There are times when you can use boundary selection for, you can use layer selection for boundary. I kind of touched on that quickly. Let me see if I have kind of something set up here. I really believe in layers and using layers to work on what, when you're as part of your CAD preparation, and to use those layers or leverage those layers for your selection process to make it easier. So when you're going to select a boundary, it's not always clear, but you still have all of your selection tools. So you can go by layer, and then you can pick by layer. You can go by color and pick by color. Now, there was a question that came up where, can you copy and paste your boundaries? Like if you have one boundary, can you copy and paste it? No, but you do have parent and child boundaries. So that gives you a little bit of flexibility there, an overall boundary and then the individual boundaries. And when you go to select your boundary, again, you're in selection mode, so you can pick and match by color or layer all the different selection styles. So hopefully that kind of covers that. Let's see what we got here. On a physical part, when would you know to use pocket in or pocket out? Pocket in and pocket out is just a cutting direction. Generally, pocket in is when you're trying to work from the outside in, and the goal would be to really have the tool start off the part and work its way in so it's not plunging into the material. With the Z-level rough standard, it follows the periphery of the wall, so it doesn't start off the part unless your boundary is off of really where the stock is. So it's really just the cutting direction, in or out, out or in, and you'll just switch that. If the tool is starting on a wall when it's coming in, you may switch it to cutting inside out to move it off that wall. Okay, so hopefully that answers that question. All right, is there a way, cusp height? Brian, there's no real way for a consistent well, I guess you may be asking, how do you calculate a cusp height? There is a formula to calculate the cusp height. We have a tool called the Machinist Toolbox. You enter in your tool radius and the step over, and it will calculate the cusp height for you. And then you can use that input value. So if you don't have the Machinist Toolbox, I recommend you get it. You can download it, machinisttoolbox.com, and that will do the calculation for you. As far as adding a formula, I mean, you can input formulas into BobCAD. They don't stay there, but you can, type in a formula. So I guess it's possible, but I would just use the Machinist Toolbox. So hopefully that answers that question. We got the hotkeys. I think everything else. Do you have to set the allowance for each feature? Well, that brings up a good point, Dana. One of the things that you have when you have individual features with single operations, and then you have features with multiple operations. And you'll notice when I'm at the feature level, see how there's nothing here, but as soon as I go to something like parameters, and this is available, it says apply to all operations. What that allows you to do is to set a value, something like an allowance or a machine tolerance. So I could set this one time, hit apply to all operations, and then it will apply that setting to all those operations. So that's what apply to all operations is based on or used for, and that's what you're looking for in that particular example. You need to select geometry. I'm not sure what you're asking, Brian. You can always email me any questions that you guys have or feedback on today's webinar. You can always email me at al@bobcad.com. That way, anything that like posting or any other questions that I may have not covered that you would like to see covered can be answered just by emailing me directly. Speeds and feeds for wood, Brian, I really just talked to your tooling supplier or your router manufacturer. There isn't a whole lot of science to it. You cut fast. With the thermwood we use in the shop down the road, I mean, we max out the spindle speed and we cut at, I don't know, 200, 150, something like that. It's less about the wood so much as it is just seeing what's going on. So there's a lot of flexibility there. It depends on your router that you have. The best bet is to talk to your manufacturer. Now, what I would do in order to set your speeds and feeds is I would set them with a feature for something that I've already cut, so that way I can use it in the future. Save it, have a folder set to wood. Instead of changing my material up here for my surface footage and chip load, I would create a feature and set my speeds and feeds and depth of cut here. Save this pocket for pine or pocket for oak or whatever it is, or MDF, and then that's how I would pull it in. I wouldn't necessarily set up a material for the surface footage and chip load, because you can easily just type it in at the feature level and save that feature. So that's what I would recommend there. The lead-in value, I'm not sure, John, we may need to address that together. The lead-in value here, the lead-in value and the top of a feature are kind of two different things. So, but the default, so we're on the same page, this feature here has a clearance plane. It's set to 1 inch, and it's grayed out when you're at the feature level. If you want to change it, you right-click on Machine Setup, and you go to Clearance, and this is where your clearance is set. So hopefully that answers that question. I think that's just about all the questions that we have here today. I really appreciate everybody spending some time. I do want to throw some polls out here right at the end. If you guys don't mind answering just a couple of these questions so I can get a good idea of everybody that participated in today's webinar, if you're still there. Again, any post-webinar questions that you have, you can email me at al@bobcad.com. We have some really good mill professional and advanced webinars coming up, so we appreciate you all spending some time here today. Also, if you'd like different times for the webinar, if you're on the West Coast or East Coast, that would really be great to just know what times would work better for you guys. So it'd be easier for you to see this information. Know that you'll get a copy of today's webinar emailed to you. Everybody that signed up for the webinar will get a copy. I'm going to close the poll down here for this one. Thank you, guys. It looks like most of you are using the version 29 software, which is great. By far, I feel one of the best programs we've ever had. Let's take a look at some other information here, if you don't mind. Just want to see how long you guys have been using the software, whether you're new users or pro users or level 5,000, as we like to say here at BobCAD. You know, there are a lot of level 5,000 customers. Burman, if you're watching this, you know you're you're 11 5,000. So I don't think I'll see you here. Probably liking that cigar on the beaches of Hawaii. But anyways, keep the poll open a little bit more. It seems like a lot of new users, which is great. If you're a new user, you're looking at BobCAD AfterDark is a great resource for you. There's lots of different training options that we have. I do a lot of videos, and you know, obviously there's the webinars, which are great to participate in. So good to see that a lot of new users and a lot of veteran users. So that's great to see. So let's go ahead and close down this poll here. Let's go to one more. This one's always a fun one to find out. Are you guys on an active support plan? Support is the technical support package, the phone support. There's a lot of things that are tied into that through the website, have to do with your post-processors and things. So you like to get a good feel. Your post-processors, the software updates, to be able to talk with Sean and Mike and Greg and you know, there's Daryl. There's a bunch of guys that are down there that if you're on a support plan, those are the guys you're talking to. So if you're not on the support plan, we like everybody to be on the support plan. So it looks like most of you are on a support plan, so that's really good. So glad to see that. Keep that up year over year. We really like that. All right, let's see here. We'll close this one out. Next to last one, what kind of CNC do you run? I wish I had a fill in here so I can get an idea of what some of the other machines are, whether you're running Haas, Herco, Prototrax. We do a lot of Prototrack customers. Really a great group there. Herco guys are awesome. The Mazak guys are awesome. So just trying to get a good idea of what controls. This helps us with posts and things like that. Keep this open just for a little bit longer, but a lot of Haas guys. So good to see that. A lot of Herco guys, a lot of Prototrack guys, a lot of Mazak guys. So pretty even there across the board, but a lot of these others, which I assume would be PC-based control machines. So there's a lot of them out there too. So thank you everybody for voting. I'll keep this open just a moment longer. All right, we'll close that one down. And then the last one, my favorite question to ask is what kind of training works best for you? And I've said this before, the kind of training that I like the most is sitting down next to a guy who knows what to do and just kind of like having them coach me through what I'm doing. You know, that's just kind of what I prefer. I feel like I get a lot out of that. I do shoot a lot of video. I watch a lot of video. I do go to training seminars. I do read books, tutorials. I mean, these are all the resources that I personally use. But I do like really working one-on-one with level 5,000 guys. I mean, that really helps bring everything full circle for me. So I appreciate everybody who came out to today's webinar. I hope you enjoyed. I hope you enjoyed it. If you, like I said, if you have questions, you can email me, al@bobcad.com. We want to do these on a regular basis. We're getting good turnouts, really good turnouts actually. So thank you everybody for participating. If there's any last questions that you may have before I go here, go ahead and get them in now. Otherwise, we'll send everybody off. Let's see. John's got a question. With the holes in the in the planar surface example, could you not use boundaries instead of making surfaces? John, that's a really good question. The thing with let's remove these real quick. what do I got here? The thing with this, when it comes to planar, right? In the standard, you run into some issues with inside and outside boundaries. And what happens is you get a direct connect is what it is. So if I extract edges here like this, okay, so I want to use this as my boundary for my planar, and I recompute this. What happens is you get this direct connect, and that's what we're seeing here. See how the tool is kind of direct connecting, it's coming over and coming down. So yes, you absolutely could use this. That is a method to use inside and outside boundaries. The thing that you'll find with using planar and inside and outside boundaries is because it does direct connect, sometimes it will carry over on some of your surfaces, okay? In other words, it will cut along surfaces that you may not want it to cut along at. So it's something that you just want to be careful with or conscious of. Again, sometimes when you're trying to remove where it's cutting or where it's not cutting, let's go to planar. You can sometimes do this by just dropping the top of job down. This isn't going to do exactly what I want here, but you can see how by dropping the top of job down, you can see how I can get it to kind of link over in those areas, and then you can also see that it's avoiding these surfaces here. So that's not exactly showing you what I want you to see there, but what it's showing you is that when you use inside and outside boundaries with planar, and again, this is mill standard, you can run into some areas where the direct connect doesn't necessarily get your toolpath where you want it to be. So hopefully that answered your question there, John. Where do you set Z-level rapid plane between moves and operations? You know, there's a specific part that I set up for this. Let me see if I have it here. This one here. Okay. So one of the things that you'll see is when you do a Z-level finish, you're going to get this direct connect. And with this direct connect, the tool is following along this this surface here, and that's really not the best scenario. So generally how I would approach this, there's a couple of ways to approach it, but generally how I'm going to approach this is I'm going to do more than one Z-level finish. So I'm going to do a Z-level finish from there to there. Let me copy and paste. I'll come in here and edit. So now we have the second one. Everything's the same, but this one I'm going to change. I'm going to say, okay, start cutting there and end cutting there, finish, and then recompute. So now I can do another group there. So what's going to happen is as it goes from this group or this operation to this operation, it's going to go up to the clearance plane, and that clearance plane is set in your machine setup. So whatever value this is, that's where that's going to go to. So it can be a little painful when you're doing multiple groups like this, when you're dealing with your direct linking, but it's really not that bad. I mean, you just go in, copy and paste. I mean, it updated. It took no time at all. Now, when you get into Mill Professional, you'll see a lot more options are unlocked to be able to handle things like that. So hopefully that answered your question there. I think that's about all I got. Let's see here. I wonder if I can sort by time. That'd be cool. Let's see what we got. All right, Dustin's already gone. Brian, hey, no problem. Great to have you here with us today. John, you can email me whatever you'd like if we haven't addressed it already, or if you've already thrown it out there. What about a time for Europe? Yes, we need to do a time for Europe. Let's see here. Steve, if you have an older version, like a DOS-based version, if it's running for you, hey, keep using it. Otherwise, I would consider upgrading into some of the newer software. Definitely a little bit different for you. Hey, Mike, thank you so much for coming in here today. Yeah, Brian, hopefully that helped out with saving with the features. Great to have you in the meeting here today, John. Dana, again, thank you so much. Steve, it was great seeing you again. Very good. All right, let's see here. Monroe, thank you, bud. Again, any other questions? I'm going to shut it down for now. Thank you guys so much. Let's see here. Let me pause it for a second. There we go. Last few slides. Thank you so much, everybody. Thank you, everybody, for participating. Look forward to seeing you in the next one. Again, if there's any additional questions, you can always call us 877-262-2231, extension 123. Thank you so much, guys.